Hello, my name is Steven Martin Salvista and my matrix number is 07DKA19F1030.
My name is Kelvin Nainal. My matrix number is 07DKA19F1064.
Hello, my name is Christine Wenang and my matrix number is 07DKA19F1052.
Hello and welcome to our presentation. Our research title is Flexural Behavior of Concrete Beam Containing Barbed Wire as Confinement. Let's start off with the introduction. Concrete is the most popular building material in the world, but it has one major problem. It is high in compression but very low in tension. So we propose to use barbed wire as a confinement material to solve this problem. We move on to the problem statement. Beams are constantly exposed to loads and stresses. When the beam's maximum stress resistance is reached, it will fail, and when that happens, it will cause injuries and harms to other people. Next are the objectives. There are three objectives in this study. The first one is to determine the physical properties of concrete. The second one to determine the compression strength of concrete cubes. And the third and last one is to determine the flexural strength of concrete beams. Then to the research methodology. These are the activities and tests that were done throughout the research. On to the material preparation. The materials that we used are cement, fine aggregate, coarse aggregate, and water. Then we pour in our concrete mixture into the formworks. Before that, we applied grease to the surface of the formwork to avoid sticking. Next, we cut barbed wires into 36 pieces, measuring 500 mm and bend as much as 30 mm to both ends. These are all the materials that we used in the study.
How do we find the weight needed for concrete mixing? This is the total weight that we needed. For cement is 40 kg, sand 58 kg, coarse aggregate 86 kg. These are the following steps for preparing the concrete mix. First, measure the material weight according to concrete grade 25 using standard weighing scales. Second, place all the materials on the ground. Third, mix them using shovel. Fourth, make a deep crater in the pile and add water. Fifth, fold the mix inwards from the sides. Lastly, continue to fold inwards and chop the pile to distribute water through the mix. Now we move on to the sample preparation. 3 layers for each sample. Take sample BW2, which is 2 barbed wires. Concrete tempered down 25 times. Add 2 barbed wire. And so on. After a day of drying, density and water absorption were tested before and after curing process. The specimen were weighed for density, and right after that, we determined the water absorption based on density. Next, the concrete beam and cube were labeled before removing the formworks. Then, the specimen were cured in a curing tank for 28 days.
There are three kinds of tests performed to achieve our research objective. The first one is density and water absorption test. Beam specimens are weighed before and after curing process. We found out that the average density before curing is lower than the average density after curing. This is due to the water absorption by the beam specimen, causing the density to increase. We also found out that if more barbed wire are used in concrete beam, the density of the sample will increase. The highest density is on the sample with 6 barbed wire, while the lowest is on 0 barbed wire. In general, there is no significant difference between 0 barbed wire and the rest beam containing barbed wire. The average increase in density is mainly because by barbed wire embedded inside the beam and water absorption. The percentage of water absorption from 0 barbed wire until 6 barbed wire is decreasing. This is due to the increase in density. The highest water absorption is the sample with 0 barbed wire, while the lowest water absorption is with 6 barbed wire. The second test is compression test. The compression test was done to all 3 of the cube specimen. The test was performed and the data was recorded as you can see in this table. All cube specimen has a different compression strength, but not any significant difference. Overall, the average compression strength is 18.23 MPa. This value will be used to be compared to the flexural strength of beam specimen. because in theory, beam specimen flexural strength must be at least 10% to 20% of cube specimen compression strength. On to the next test, let's take a look at the flexural test. The flexural machine that we use are 3-point bending machine. This test was performed on all beam specimen and the data was recorded. The highest average of flexural strength is the sample with 6 barbed wire, which is 9.36 megapascal, while the lowest is 0 barbed wire, which is 4.72 megapascal. The percentage of the beam specimen without barbed wire compared to the concrete cube is 23%, which is higher than the minimum standard of concrete beam flexural strength. The percentage of flexural strength for the concrete beam containing 2 barbed wire, 4 barbed wire, and 6 barbed wire is higher with an increase of 31%, 44%, and 51% respectively. Evidently, the flexural strength increases dramatically due to the contribution of the barbed wire. In conclusion, the average density of 12 beam specimen is 2372.5 kg per meter cube, with 1.3% of water absorption rate. The cube specimen has an average compressive strength of 18.23 megapascal. For the beam specimen, the flexural strength increases with the increase of the number of barbed wire. The beam specimen with 6 barbed wire shows the highest flexural strength of 9.36 megapascal. The result reveals that installation of barbed wire improved the concrete beam's flexural strength and ductility. In comparison to compressive strength, all beam specimens have a flexural strength that's greater than 20% of the concrete cube compressive strength. Moving on to suggestion. To ensure that barbed wire can reach its full potential, it must be put in the tension zone of the beam specimen to increase its ductility and strength. Barbed wire can also be applied in concrete building components such as slab. Using the same concept as the concrete beam, barbed wire can control and slow down the cracking rate of concrete.